from University of Tokyo, and today I talk about the COLLADA robot format. So I'm from the JSK Robotics System Laboratory. So as a robotics system laboratory, we have a lot of robots. So this is our laboratory. We have many humanoid robots and small robots and other robots. So since we have many robots, and each robot has its own robot platforms. And for example, here we have a PR2, and the PR2 is a ROS system. And for example, Rosen are interested in the motion planning, and he uses OpenWave. And we use Lisp systems. And when we use HRP robot, we use OpenHRP. And also we have a Darwin for the Darwin, and Darwin Open. And now robot use a choreograph. And Webbot is a very nice simple simulator. So robotic software platform is very nice and to share. But in order to share the research tools between the robots, I think the most missing link is the standard robot file format. So in this picture, people usually talk about the interoperability or interconnection between the robot systems. So this is this link. But each system uses their own robot models. So I think the important thing is to design the standard robot file format so that every robot can share the result or share the robot models. So if you make some result from this system, then we want to use that result from this system. But if we don't have suppose if you don't have a common robot platform, it's very hard because you first have to convert the robot model from this system to the another. Okay, so I think there is a two way to define the robot format. So first idea is to define the robot file format standard. For example, we look for the kinematics and geometry and physics, and for example, sensors, actuators. But from our experience, we found out that even if we try to carefully select the information that used for the robot standard format, there will always be information that another developer wants to insert. So I think the important feature or idea to design the standard robot format is content scalable. So not adding new information to extend the original content, but the robot file format must be the feature to add new content and manage new content and allow extensibility of existing content with the scalability. So we choose the COLLADA for the robotics file format. COLLADA is designed by the collaborative design activity, which is XML-based open standard. And this COLLADA is originally started as a 3D model format, but now the most recent version supports the physics, kinematics, and B-Rep Prime. So, and it's currently supported by many commercial or open CAD systems like Blender or SolidWorks or a library called the Open Scene Graph. So here is some example of the COLLADA definition of the kinematics. So it can define the mimic joint, like if we have a mimic joint at here, and by controlling the angle of this mimic joint, it can change the joint angle of this four joint. Or you can model this kind of very complex closed link robot, like have a video issue. Yeah. So this seems very simple, but it has only one actuator, and it controls 4 or 5 joints. So by using COLLADA, you can model this kind of very complex kinematics models. So, but the COLLADA, if you have experience on the COLLADA, COLLADA is very difficult to manage it because the core content management tags to dictate the reference structures. So geometry or kinematics or body or fixed body, such a instance is used as a libraries, and then you have to define the different types of scenes for the graphics or physics and kinematics. So not as a robotics format, you can't, the COLLADA didn't define the one-to-one relation between the graphics and the kinematics, but it defined separate scenes. So this is how you define this simple model using COLLADA, and this is a library to define some joints or links, and these are seen to define the kinematics or articulated systems or physics. But since COLLADA uses a library and a scene, this is very extensive. So if you want to add new scenes, you just use by combining these library and define your new scene. And we define the following the robot-specific extensions. So there is 5 types of the information. One is a manipulator that holds a subset of the joints in the robot that defines the hand or the arm to, for example, calculate the inverse kinematics or apply the motion planning. And it also we added sensors, and we added actuators, and we also added a collision group. So by using this information, this allows the robot to have multiple collision models separate from the visual information. So if you want to have a very nice visualization of the robot, but when you calculate the collisions in the robot, you can define the more simplified model. And also we can add the mimic equation in the COLLADA model. So, but we had a COLLADA robot database on the website, and currently we provide the 14 sample robot models, including the Barrett arm, Puma, Kuka, PA10, Katanam, and Shunk, and PR2, and the Kawada Hiro robot. So here is, so if you have internet access, you can see this page, and we have this kind of the model in the web, and if you click this, so you got this file. And if you want to download the COLLADA file, just click there and you get the models. And also this homepage provides some C++ code for the inverse kinematics. So if you want to calculate the arm and torso inverse kinematics, you download this code, and this is automatically generated in the what we call IK first software. So this is to solve the complete solution of the inverse kinematics of the robot. Okay, so let's back to the slide. And from now we show the robot system that currently support the COLLADA. The first one is the OpenHRP3. OpenHRP3 is used for controlling the robot. So for most of the humanoid robot in our laboratory use the OpenHRP3. And of course OpenHRP3 has its own file format based on the VRML. And we had a converter to export the COLLADA file from this OpenHRP3 robot model. And also we added the feature to load the OpenHRP3 COLLADA model into the OpenHRP3. So I'd like to show some video. So if you want to export the VRML file defined in the OpenHRP platform to the COLLADA file, you just run this command, and then you get this COLLADA file. So in order to check COLLADA file, you just run. So you see the HRP4C robot model in the COLLADA. And you also, okay, so of course OpenLab has a very nice support for the COLLADA, and you can, so this is what I showed previously. You can use HRP4 robot originally defined in the VRML format run on the OpenLab. And also if you we developed the COLLADA support for the ROS system, and so if once you have a COLLADA file format, that robot can be run on the ROS robot. So let's see. Planning. COLLADA. Just a moment. Model. So this is OpenLab, and this is a ROS robot format, ROS viewer, and you can add, for example, coordinates information. You can see the coordinates information of the robot like this. And if you are familiar with the ROS system, you can see that topic equal. Oh. So if you are familiar with the ROS system, you can understand that this system publishes a TF for this robot. And finally, we have been using the LISP system for more than 20 years, and we also had the COLLADA to LISP converter for these systems. So, for example, so first you convert the COLLADA file to the LISP file, then you load into the LISP interpreter and show the result like this. So here is you see the robot model, and also you see the geometry primitives. And we use this for the top-level interpreter or rapid prototyping. So here is the conclusion. So I think the common robot file format is a key to share the different types of the robot platforms. And we choose a content scalable file format. So we choose, as a content scalable file format, we choose the COLLADA format because no matter how hard the developer attempt to unify the Robotix information, there will always information that another developer wants to insert. And we propose the Robotics specific extension, and we are currently working on supporting the COLLADA to the major robot platform such as OpenHRP3 and OpenLab and ROS and Useless. So thank you very much for attention. Also, we have the instruction of how you design check our demonstration in the slide. So you can download from the website.
Can you show the robot extension website?
Oh, which one? Which? Robot extension. Yeah. So, so everything is defined in here. So if you refer this page, I think you can define your own robot models. And if you don't understand,